Good evening, everyone. In this lecture or the lab, we can say that I'm going to write a program for a filter. And the filter we are going to do today is a low pass filter. We will do a high pass filter and a band pass filter subsequently. So if we have a sampling frequency equals to 100 and the time duration, if we want to calculate, then will be equals to 1 divided by fs. And time is basically your 0 to t. I'm going to explain it, some meaning of this. So there's a difference of use of your colon and semicolon. Semicolon is used when you don't want to print the values of this variable t on the command window, let's say capital T or fs. And this colon is used for defining the basically the range. So if I say t is from 0 to 1 colon 5, then it has values starting from 0 ending at 5 with a step size of 1. Okay, so now if we have a signal s equals to sine to pi is defined as pi in MATLAB, frequency equals to 10 and t. So to this signal we will add a noise and then we will try to filter the noise. So let's say the noise is a random behavior of the interferences or the, can say, the sounds which are around the signal. So we generate with the help of random number signal in MATLAB, and the range of the generation of this noise will depend upon the time axis. So it will depend upon t. This is your size of this noise, and we add these two signals, S and noise. And if we plot it, then we will see that run it, then we see it, instead of being it a sinusoidal wave, it's basically a wave which has noise randomly added at different points. Now, to remove this noise, we need to generate a filter. We design it. There's a command in this MATLAB, design FILT for low pass filter, low pass, that is FIR. It's a type of filter we use. Then filter order is your 5. Then the cutoff frequency of it, because it's a low pass filter, so there must be a cutoff frequency. Let's say it is equals to 11, and sample rate of it is, means how many samples we are taking, is equals to your sampling frequency. I'm going to explain it in lectures what is your sampling frequency means. And we now want to plot it, but first of all we need to do the filtration on this signal X. So we designed this filtering action, and then we are going to use this D, X. And now if we plot X and we say hold on means that you will see the signal X with your another plot which we are getting after using the filter. We run it, then we will see the signal like this. So this is the original signal and this is the signal after filtering it. Now we can do something else also on it. we use another signal and we use another command FILT, and we say D comma X, and we say again hold on, and then we plot your jet. We run it, then you will see that we have now 3 different signals. So in order for you to understand it, let me remove this part. So cancel it. Now run it again. Valid expression. So we run it. So now you can see that all the signals we are getting as an output, they are in phase with the signal which is including the noise. Earlier, if we were plotting Y, let me cancel it again. And if I plot Y, then you can see that the signals were out of phase. So this is the signal with the noise, and this is the signal after we are getting using the filter. But if we use filt dx command, then the output we get in the same phase. So depending upon your requirement, whether you want to get the output in same range, same phase, or out of phase, you can use any one of these commands. Thank you.